This lesson is section 4-1, Extrema on an interval. So what exactly do we mean by extreme values? So let's look at this function. This is a function over an interval from, from x equals -2 to x equals 6. And let's see what they mean by extreme values. If you look at the point 6, 4, that can be considered the absolute maximum. By absolute maximum, we mean this is the highest point over this entire interval. So this is the absolute maximum. If in turn we look at the point 2, 0, that can be considered a local maximum. It's not the absolute maximum, but it is a maximum that occurs on this interval, but it doesn't happen to be the absolute maximum. Now if we look at the point -2, -3, this can be considered an absolute minimum, all right? This is the lowest possible point on this interval that we're talking about. So that's considered to be an absolute minimum. And finally, if we look at this point here, which is 4, -2.5, that's considered to be a local minimum. So that's a minimum, but it's not the lowest minimum on this interval. So here you can see we've defined absolute maximum, absolute minimum, local maximum, and local minimum. So how does this relate to calculus? Well, all of these points that we've talked about can be considered to be critical points. And critical points are when the derivative is 0 or undefined, okay? So this is where calculus comes in. If we take the derivative of this function, where it's 0 or undefined, can be considered to be critical points. And if we look at, for example, the local maximum, we can see there that the slope right there is going to be 0, or the derivative is going to be 0. The same with the local minimum. So now let's look at an example. Let's say we want to find the critical points of this function. F of x is equal to 1/3 x cubed minus 9x plus 24. So we're simply going to take the derivative of this function. And if we take the derivative of this function, it comes out to be x squared minus 9, which can be factored into x plus 3 times x minus 3. So if we set that derivative equal to 0, that will define the critical points. And we can see here now that the critical points for this function are 3 and minus 3. This is where the first derivative is 0. So let's take our example a bit further. Let's see if we can find the absolute maximum and minimum values for the following function over the given interval. So our function is x cubed minus 3x squared plus 1, and the interval is from -1/2 to 4. So the first thing I'm going to do is find the critical points. In order to find the critical points, I need to take the derivative of the function. If I take the derivative of this function, I get 3x squared minus 6x. Now, if I set that equal to 0, I can factor out a 3x, and so I got 3x times x minus 2 equals 0, and then set each of these factors equal to 0, so my critical points are 0 and 2. Now, I was asked to find the absolute maximum and minimum. Well, I've got the two critical points here, but I also have the endpoints of my interval. So I got 4 points that I have to look at here. I have to look at the endpoints of my interval as well as these critical points. And from that, I should be able to determine what the absolute maximum and minimum values are. So the first thing I'm going to do is take the function and plug in the lower level of the interval. In other words, I'm going to plug in -1/2 for x in the original function here. And if I do that, I come out with 1/8, all right? Now, I also need to take the upper limit of the interval, which is 4, and plug that into the original function, and I come out with 17. So those are the values of the endpoints of the interval. Now let's look at the critical points. So first of all, if I plug in 0 for x, the value of the function becomes 1. And if I plug in 2 for x, the value of the function becomes -3. So here's my 4 values for critical points and endpoints. Now, the absolute maximum is going to occur at the greatest value of this 1/8, 1, -3, and 17. So 17 is obviously the largest value, so that's going to be the absolute maximum. The absolute minimum is going to be the smallest of these numbers. So I got 1/8, 1, -3, and 17. So -3 is the absolute minimum. So the absolute maximum occurs at x equals 4, and the absolute minimum occurs at x equals 2. So this is how we can use calculus to determine the absolute maximum and minimum values over an interval for any particular function.